Hey guys, welcome back to chapter 13. Today we are going to practice our newly acquired skill, the ice table. So here is our problem. So we have the following reaction. Carbon monoxide reacts with hydrogen to produce methanol. A reaction mixture initially contains carbon monoxide 0.5 molar, hydrogen 1 molar. At equilibrium, the carbon monoxide concentration is 0.15 molar. What is the value of the equilibrium constant? So this talks about initial concentrations that immediately tells me that I'm going to need an ice table. So let's get our ice table onto the screen. See. Reactant, carbon monoxide. Let's put the coefficient in. Hydrogen and methanol. All right. So initially it contains, so that initially is going to go on this I line. So 0.5 molar carbon monoxide, 1 molar hydrogen. It does not mention the initial concentration of methanol, CH3OH. This is very, very common. If it does not mention initial concentration for anything, you can assume that it's 0. So no mention of CH3OH, we're going to assume initially it was 0. Remember, the whole purpose of this exercise is to fill out this bottom row. So once I fill out the values down here at equilibrium, I can then plug those values into the K equation. And in this first type of example that we talk about, we can completely fill in the table with numbers. That's not necessarily going to be the case in the future. Okay? So the purpose of this exercise is to fill out this bottom section with numbers. So let's see what it gives us. At equilibrium, the concentration is 0.515. So carbon monoxide at equilibrium is going to be 0.15 molar. Having at least one of the concentrations at equilibrium is super helpful because now I can solve for what was that change? How much did it change by? So I'm going to take 0.5 minus 0.15. And I know that the change here is 0.35. Okay. I'm going to jump over to the product. So for my reactant, I see that the change here is it went down by 0.35. For my product, the change has to be positive. Why does the change have to be positive? Well, the product started with a 0 concentration. Would it make sense for that concentration to go down again? No, a negative concentration doesn't make sense. That doesn't make sense to me. So I know that the product starting at 0, the only direction for it to go is up. So it's going to be a positive change. And then that makes the reactants have to be a negative change because we make the product by using the reactant, right? So if my reactant changed by 0.35 molar, I know my product is also going to change by 0.35 molar. It's going to increase. Now I saved this middle one for last. This one is also going to go down, right? It's a reactant, so I know it's going to be a negative change. And it's also going to go down by a factor of 0.35. But what do we also have to consider for this one? We also have to consider that coefficient, okay? So for every 1 molecule of carbon monoxide that we're using, 2 of the hydrogen molecules get used. So this is going to go down at a rate of 2 times 0.35. Now that my change row is filled out with numbers, I can then fill out this equilibrium value with numbers as well. So down here, my product is going to end as a positive 0.35 molar. For this middle one, the change is 0.35 times 2, which is a 0.7 change. And then 1 minus 0.7 means at equilibrium, this guy's going to be 0.3. Equilibrium concentrations in place, we can plug them into the K equation. So remember, K is always products over reactants. So products is CH3OH. Concentration of reactants at equilibrium, that's carbon monoxide and hydrogen. And we square that, remember, because of the coefficient. So plug in our values, we get on the top 0.35. On the bottom, 0.15 and 0.3 squared. And I'm breaking this up just to make it very explicit. You could probably combine these steps in your calculator, that's fine. So we saw 0.35 on the top. I'm just going to clean up this bottom a little bit. So 0.3 squared times 0.15, and I get 0.0135. And then divide those two numbers. K equals 0.35 divided by 0.0135. And we get that K is 25.1. So to summarize, we're given the initial concentration of our reactant, so automatically we're going to have an ice table. We're given the equilibrium concentration for one of the molecules. We then can fill our ice table out completely with numbers and plug that into the K equation. I hope you guys found this helpful.